So we're going to continue solving logarithmic functions. We're going to look at different type of question now, so type 2, and then we're going to learn something called the property of equality. So you would still write as a single logarithm on both sides if necessary now. So what's going to be different about these equations from the previous is that you have logarithm in front of every single part of your equation, whereas in the previous question you always had a number on its own, which allowed you to put it in an exponential form. Step 2, this is the rule called the property of equality. So this is the rule that's kind of all about this question. You're going to set the arguments equal to each other. Note that the base number must be the same to do this, which it will be in your solving questions. So we learned with the previous example that this would be a true thing. We can set your arguments equal to each other. Then you're going to solve for x or whatever variable, and then check for your extraneous roots, meaning your arguments must be positive. So let's take a look at the first one. So you want to write a single log on both sides. I already have a log by itself on the left, log by itself on the right. So you're ready to just set the arguments equal to each other. So 2x minus 1 equals 11. And isolate the variable. Move 1 over. And x equals 6. Check for extraneous root. 6, if you plug that in, you're going to get a positive number. So it's true. Now, almost seems too good to be true. It is going to work every time. I just want to show you sort of prove it to you using exponential form. If I had moved everything to one side, now this is not how I would want you to evaluate this question, because then you're not demonstrating the property of equality, which I may specifically ask for. But if I move this over, then I actually do have a number to work with, an exponential form. I could write this now as a single logarithm on the left side and put it in exponential form like we were doing previously. And then I'd get 2 to the 1, oh, this is base 6, I apologize, sorry. And they have to be the same base numbers. Okay, so I'd have 6 to the 0, so anything to the exponent 0 is still going to be 1. And so now you're going to solve for variable, so cross multiply. 11 equals 2x minus 1. So I've done 1, 2, 3, 4 steps, and on step 5, I've got to my first step here. And of course, you're still going to get the same answer. So property of equality allows us to get to our solution rather quickly. And it's also a property and an outcome that I'd like you to make sure you know. But this proof is worth sort of just seeing how this is true. So you're going to just set the arguments equal to each other and solve from there.